Hello and welcome to the Rally Point with Dominic Fielder, author of the King's German series, and myself, Rob McLaren, author of the Jobert series. Hello, Dominic Fielder.
Hello, Ron McLaren. How are you?
I'm really well. I'm very, very well. Each month at the Rally Point, we catch up with friends who enjoy the Napoleonic period. Now we record the first 30 minutes of the gathering. Once the recording is over, we remain online and the conversation continues. And this month, we would like to welcome Dr. Stephen Summefield to the Rally Point. Stephen is a Napoleonic specialist, a prolific publisher of Napoleonic information and research, and is based in Kent in southern England. Hello, Stephen.
Hello. Nice to be here.
Wonderful. Over to you, Dominic.
Hello, Stephen. Stephen, I just want to check in Rob's introduction. It was a long time. You haven't managed to write another book in the introduction, that little space of a few minutes.
Well, there's 12 books will be published in next month.
Excellent. I'm looking forward to that. And I'm really looking forward to siege artillery. Now, remember, one of the main drivers of Rally Point is to know less than when we started. That, as in, we have more questions. And I know we're going to have questions by the time we finish this tonight. But also, tonight, for the first time, we can actually be accused of being vaguely topical in Rally Point. And I'll tell you why. I'm about to move house from West Devon to North Devon. So this is topical for me. Siege artillery. The siege I've written about, Dunkirk, 1793, contains Admiral McBride. There's an Admiral McBride pub in Plymouth, the city of my youth. Admiral without a fleet to conduct the siege of Dunkirk, which was a siege that was conducted without siege artillery. So one of the great British sieges, and it was conducted by the Duke of York at a time when we just lost our Duke of York for administration and legal purposes. So there you are. Amazingly topical. Over to you, Stephen. Tell me more about siege artillery.
Right. We will start with looking at, this is the technology behind garrison siege and naval armament. There really isn't very much difference in the cannons. It's just what they're actually resting upon, their carriages, really. So that's what I'm sort of talking about. Primarily, this is iron ordnance. I know the French spent a huge amount of money on brass and bronze guns and so forth, but we covered that in the last time I spoke. So siege artillery are long guns, howitzers, mortars, and carronades. Naval ordnance is really restricted to long guns and carronades. And garrison and coastal artillery are long guns, howitzers, mortars, and carronades. So it's, again, you can see that there's a theme or a commonality there. British ordnance is, again, sort of going, you're talking about the heavier ordnance, the siege artillery, 18 and 24 pounders primarily. Then you've got the 8-inch howitzers, 10-inch mortars, and the 68-pounder carronades. That really is mirrored by the French, but primarily they were using bronze guns rather than iron guns. We covered a lot of what about how a gun works. It's, again, sort of going, it's about a glorified air gun. So it's, again, sort of going, you're building up the pressure and so forth using gunpowder. Now, the difference between loading a gun for naval purposes is you put a wad in there. The reason why you put a wad in there is so the ball doesn't roll out when the boat pitches. This is the Blomfield 24-pounder. These were used both in naval and in sieges and the later sieges. And this is actually a Carron piece which was used in sieges in the Peninsular War. Production of guns. It's again sort of going, really the first proper gun rather than a bombard is about 1450, when you had trunnions. Trunnions are those knobs on the end to actually allow elevation and depression, whereas with a bombard you have to actually jack it up or take the whole piece or down. So it makes life a lot easier. Again, casting in the Weald, if you know Kent, we've barely got any trees, and that's because of Henry VIII. He cut them down to make charcoal to go and smelt his guns. Again, talking about solid casting. Solid casting is a great advantage over putting a core in there, because you're able to actually get better, denser iron or brass or bronze. So that's a lot easier. You remount from solid. You can actually do that very accurately, whereas if you're doing it from vertical boring, which is what we've got here, again, sort of going any slight differences, you get different thicknesses of the gun tube. That's an example of a horizontal boring machine. In that case, this is bronze guns. That's how it was powered. The originally powering was by horsepower or mules, and that's the brass foundry. On a visit to the brass foundry, Wilkinson thought, that's a good idea. Can we do this for iron pieces? So he patented horizontal boring machines in Britain, which caused a lot of issues over it. And finally, the Royal Navy quashed the patent because otherwise they couldn't get any other gun manufacturer to go and use this advanced technology. Primarily in the Napoleonic period, we're talking about iron Blomfield guns. John Wilkinson patented the horizontal boring machine, which I've said earlier. The failure of the Carron pieces was due to the change in the source of the fuel. So instead of using charcoal, because literally England was running out of wood, we changed to coal. Coal has a high sulfur content. Sulfur up to sort of going now into about 1% or 0.5% would make the cast iron very brittle. So this caused a real problem with the Royal Navy. As you probably noticed, that it was really only fixed in 1795. So for the first few years of the Revolutionary Wars, the Royal Navy was really running out of guns that they could use. It's rather inconvenient on a gun deck to have a cannon next to you go and explode. And you've got big shards and splinters and so forth. This was sold by Wilkinson by buying out every single Wealden cannon, which has practically no sulfur in there, and blending in effect a 50-50 with the coke cast iron. And again, sort of going, you can see that there was still an effect upon the guns. You're talking about 496 fleet guns were condemned because they weren't actually safe to be used. This is the horizontal boring machine that was used by Wilkinson. This was using water power rather than horsepower. Garrison artillery. Simply, they are very like, if not exactly the same as naval trucks. And the differences with the carriages is simply the wheels. You don't want to have iron wheels on a wooden deck, because it would actually cause them to produce ruts in the deck. Where garrison artillery, they've got iron wheels. This is an example of a cast iron 18-pounder on a garrison carriage, and you can see those cast iron wheels. Siege artillery is simply using the same barrels in effect, but putting them on a travelling carriage. Travelling carriage means that you've got a 5-foot wheel that's much heavier than you would have on a British field piece. So as you can see here, you've got the cross section. These are by Dupin, who was a French spy who came to Britain just after the Napoleonic Wars in 1816 and drew from memory all these various plans. Interestingly, these are practically the only contemporary plans we have of the British systems, which is interesting that we have to rely upon a Frenchman to do so. These here would have wooden axles rather than the iron axles for the British field artillery. Mortars. Mortars are very important in sieges because you want to lob a shell or a bomb, as they were referred to if you're talking about mortars, over a wall. These are hollow cast balls filled with gunpowder. The most important thing is dealing with the fusing of them, and again, sort of going, that's where you have to rely upon bombardiers and making sure that they actually got the ranges correctly. It's very difficult if you have firing a mortar or a howitzer and so forth. You want it to actually explode over what you want, rather than land on the ground and somebody can go and extinguish the fuse. You can use for short range musket balls and so forth in a mortar, and this is really used in a defense rather than attacking in a siege. Carcass is always forgotten, especially by wargamers, as very important in burning down buildings, because if you want to actually get people out of a building, they don't want to stay in a burning building. The elevation was normally about 45 degrees. Some mortars you could actually elevate and depress. From that, some were actually fixed. The way you change the range in those occasions is actually the amount of charge that you're going to be putting in there. So you could use a quarter charge, half charge, full charge, and so forth, and you would get different ranges. This is on top of a Martello tower. This showing another type of carriage that you would use in defense. This is where you could actually rotate it through 360 degrees. Napoleon the sieges, again, sort of going, I could probably sort of talk about this for a long time, but it's trying to give you a quick look at it. Napoleon learnt from the Revolutionary Wars to avoid them because he wanted short, sharp campaigns. So he had real problems at Genoa. He had the difficulties over Toulon. It was the change of pace of the warfare, and really it made it less relevant. The other importance is that sieges in the peninsula are extremely important because there are only certain roads that you can invade Portugal or Spain from, and these are dominated by fortifications. The most important really is that no fortification would surrender with honor of arms. This means that many, many people on both sides died for little cause other than it would take a little longer to go and do. You hear about the atrocities, and that was caused simply by changing the rules. You could surrender with honor of arms if the besieger would actually put a hole in the wall that could be then successfully attacked, and then the defender could march out with his arms and flags, etc., and in effect march back home with the honor of arms. He avoided sieges, Napoleon avoided sieges and lightning campaigns, as I've already said. Again, this was short term. It ultimately failed because he went to arid lands like Spain, Portugal, and poor roads. Again, you start thinking about Russia. He failed miserably in trying to take Riga, which would have actually helped because he potentially could have used seaborne and the rivers to resupply his army. And again, we're back to logistics. Wellington and sieges. Well, Wellington didn't comprehend the technical side of war. In the Convention of Sintra court-martial, he made a statement that he couldn't see a difference between 18-pounder ammunition and a 24-pounder gun. Yes, an 18-pounder ball would actually fit into a 24-pounder, but because of the windage, it wouldn't go very far. And he didn't understand that different 24-pounders had different calibers, different bore diameters, that he supplied. He was supplied with Russian artillery for some of his siege train. And you've got his commander of the artillery, Dixon, complaining that the balls don't fit in the Russian 18 and 24 pounders. Generally, he lacks siege artillery, engineers, and above all, he didn't really have the time. He learnt how to do sieges by throwing men at walls, which worked very well in India, where you've got quite a lot of the walls were actually made of mud. But remember, he couldn't afford to give the French a siege train if he retreated, which meant that he could take the border fortresses. Finally, there was a siege train right early on, but Wellington refused to use it for that reason. Finally, in 1813, he had a competent siege train. 18 long 24-pounder siege guns, the medium 24-pounders, which means that they were either they're probably 8 foot long rather than 9'6" long. 18-pounders, iron 68-pounder carronades, 8-inch howitzers, and 10-inch mortars. Now, this is again sort of showing how ridiculously close you need to get to be able to go and do any real damage to your opponent. 300 meters is ridiculously close. This is why you'd be digging parallels and trenches and so forth to try and move your batteries forward, etc. Embrasures are those crenellations on the top of the wall. So what you're trying to do is get rid of the enemy artillery, which means that you can bring your artillery and the infantry much closer. It's again sort of looking at that it was a very, very good using earth rather than stone. And again, sort of you're looking at the heights of the walls and that. Remember that artillery destroyed the idea of building high walls. because all you had to do was knock down the base and the whole wall would collapse. But now using very thick, angled defenses quite often would defeat the artillery. This is an interesting sort of penetration coefficient. So you can see the different types that you're talking about. If you had a sand mixed gravel and so forth, it really wasn't very good. But if you've got something that's got a high clay content, etc., that gives you over twice the amount of defense against penetration. These have actually come from French tests that were done just after the Napoleonic Wars. So again, you're looking at the different penetrations, the difficulty, again, sort of like going of ranges, and why you want the heavier the gun, the better, to give you the better penetration, because the velocity is kept against the air pressure that it's going through. These are masonry penetration coefficients. So again, it's looking at the brick. And again, you think about this and go, well, why did the walls at Waterloo, at Hougoumont, and so forth stand? Especially when the wall in the garden perpetually falls over, because it's only got one brick width of wall. So I've never really understood that side of why that defense worked so well. Right, we're now into the Royal Navy. You consider a first rate as equivalent to an aircraft carrier. Again, there's differences, and we can discuss that, but it's the prestige of it. It was a complex and technology-driven creation. It was the most complex military creation, or and you've also got the Royal Navy drove government policy and the war. It was a naval strategy that Britain followed. Britain ran out of trees. Trees need to be over 200 years old to build a warship, because they need to be thick, long enough, etc. The importance of the Baltic and Russia is where we got the fir, spruce, hemp, and tar. The fir and the spruce are, of course, used for the masts in the main and some of the decks. Hemp is important because that's the raw material for ropes, and tar because, again, sort of going, you're wanting to keep or make sure that your ships don't sink. And it's again sort of going how important the rope is. I mean, I won't be talking about this, unfortunately. I won't have time to talk about the importance of rope. But rope, the best rope in the world, was made by the British. And that was quite often the most sought after material on captured ships by the French and the Dutch. Oak came from North America. It's again it's a different type of oak. But again, most of the ship or the outside of the ship was made of oak. Now, if you're in Southeast Asia, you would make ships out of mahogany. Superb. The problem is the splinters themselves would actually cause very, very bad sores and infection and so forth for anybody that was inflicted by it. And it's heavier. It's more resistant to the sea, very resistant to corrosion or rotting. So again, sort of going, those are the ships that were mainly made for the East India Company, and a lot of those East India Company ships were taken into the Royal Navy. Gunpowder, Why do you think that Nelson had was a count in a particular area? That was because of sulfur. Sulfur was so important, and that's why the British had, throughout the whole of the Napoleonic Wars, a contingent, and a large contingent, in Sicily. Potassium nitrate, you need good quality potassium nitrate. That was a monopoly by the East India Company, and they made a lot of money. And again, sort of like going the other ways of making potassium nitrate was normally from urine. Then you have British coal, copper from Cornwall, etc. So these are giving you an idea of where these different types of timber constructions were used. Oak for the hull and major structural members. Again, oak is a very slow-growing material. Elm for the deck planking, keel, stern post, resistant to seawater. But again, we were running out of that. Then you have the fir, spruce, and pine for the masts, yardarms, and decks. Beech for the furniture, fittings, and planks, because it's nice and light. It's relatively cheap. It's fast-growing. And then you've got lignum vitae, which is a black wood. That there, hopefully, you can see in the heyday of Chatham Dockyards in 1800. Warship construction. Once the timber frame for the hull was constructed, it was planked inside and out, with the planks laid edge to edge. This was a carvel type construction rather than edge to edge. They were caulking, ramming oakum. Oakum is just the hemp from old ropes and hot pitch to actually seal the seams. The supported timbers for the interior were added followed by the decks. The hull was completed by the addition of various rooms, lockers, hatches, etc. And the fittings were mainly of iron. Again, you had to actually make sure that those were well painted, because salt water and iron cause considerable amount of rusting. The most important advance really for the British was the instigation of using copper bottoming of their ships. This reduced shipworm and other male creatures, stopped it fouling, means you could actually sail faster, etc. Ratings of ships. This is really an invention of Samuel Pepys, Secretary to the Admiralty, where he was trying to explain about the different size ships and the importance and so forth. He came up with the rating system. Again, the classifications were revised over the century or the few centuries. HMS Victory was laid down in 1759. Well, it wasn't completed until 1765. That was after the 7 Years' War. That's why it was put in ordinary, which means it was taken out of the water, and you're trying to actually preserve it. But it was only commissioned in 1778 because of the American War of Independence. You're talking about a huge number of trees, 6,000 trees, displacement of 3,500 tons, 26 miles of rope. I mean, again, Rob and I enjoyed looking at, and that was only a few fathoms, 220 yards of rope that was being made. Also, you look at the huge amount of copper that was used in copper bottoming. Again, you had about 100 guns, 104, 98. Various times, the Victory had different amounts of guns. This is where you talk about, is it a new ship or is it not a new ship? Remember, it cost 13 million to make, but it went through some real large complete refits. And when you say a refit, means a rebuild. There is practically not a single piece of wood left in the Victory that goes back to when it was built. And probably there isn't any, or there are only a very few that are from 1805, because again, it had 2 complete refits after the Trafalgar. As you can see there, that's where you would have the copper bottoming. I've coloured in orange. These are looking at the distribution in 1794 of the different ships that were available to the Royal Navy. And again, sort of like going, most of them were in the 3rd rates or in the frigates. 1st, 2nd, and 3rd rates are termed ships of the line. 4th, 5th, and 6th rates are termed, in effect, frigates. Frigates are there to cause annoyance, to cover convoys, and that was what they were really doing. You can see the huge expansion of the Royal Navy, and this is 1814. So they've increased the 1st rates and the 2nd rates. The 3rd rates have gone up by about 30, and they've practically doubled the number of frigates. And you look at the number of guns. You're talking about, you've doubled the number of guns. You've got 22,258 guns. This is a Royal Navy naval carriage. This is again a Dupin drawing. And the main difference you can see there, these are wooden trucks on wheels on the carriage. Carronades. Carronades are very, very important. It was an attempt for the Carron Company to be able to make guns for the Royal Navy. They were initially made for merchant vessels because you wanted a small, light, but very effective weapon that had a large bore, which means it could fire a lot of canister out of it, or a hollow ball. This is a 24-pounder carronade, which most British ships were using, the 1st rates, 2nd rates, and down into the frigates. There were some frigate armed with carronades, which weren't that successful because people learnt that they could keep at long range and not be harmed by the carronade, because it's a relatively short distance weapon of about 500, 600 meters. This is a traversing carriage rather than a truck carriage, which you saw previously. And this is able to, going through a porthole, you're able to actually traverse it. That's the huge smasher, the 68-pounder carronade, and that's on the HMS Victory. Cast iron round shot, again, sort of going, you could see the difference at the bottom. You've got the 6, 9, and 12-pounder. They've got sabot. Sabot is a piece of wood, very important because the pressure will be built up against the sabot. So you're able to get higher velocities out of it using a sabot than you would do just using a round ball. But also it's important is look at the relative sizes. The weight and so forth, you don't double the diameter going up to and doubling the weight. So it's important just to bear in mind that a 6-pounder and a 12-pounder, a 6-pounder is about 9 centimeters, a 12-pounder is 12 centimeters. So there's not a huge difference. With a cannonball, it's again sort of going, it's going to knock limbs off and so forth. But again, what's an interesting thing is there's a number of occasions where people were killed, but there were no injuries or no mark of injuries on them. And this is wind of a ball. This is by just sheer pressure that people were killed. Immobilizing ships, again, you've got chain shot, bar shot, and round shot. You're trying to fire at the rigging or the mast to disable. The British invariably fired at the hull, but that was simply because they got that close. The French attempted to fire at the hull, but because of their they were using a less good ignition system, training, and so forth. They would be lucky to hit the ship at about 500 meters because of the rolling of the ship. And it's again timing. And remember that ball gunpowder weapons in effect give you an arc, not flat firing as you would think about modern smokeless powder. Triple shotting, again, sort of going, you would only want to do this when you were literally side by side. That you were talking about 50 meters, 40 meters, or literally locked together. And again, sort of going, that would take time to prepare. And this is why you would have the order to do this before battle had commenced. You would then triple shot because you need the time and making sure you don't have any accidents, etc. Also, the importance of having reliable guns. And you also had better gunpowder, which meant you didn't need as much gunpowder, which meant that you could actually have triple shotting, where in the French and the Spanish, because they had longer gunpowder charges, not as good guns, and did not use gun locks, there was issues over that you couldn't do anything better than double shotting. Grape shot, again, we use the term grape shot for heavy canister in field. That's what a grape shot actually is. You've either got the cannonballs and you've got metal plates, iron plates between, or literally it looks like a bunch of grapes that you've got over the top. You've got in effect a Hessian bag tied with it. This is what we're referring to really when we're talking about grape shot in the battlefield on land. We're talking about large musket balls or larger balls than something a short range would have very much smaller balls. These are the ships of the line. You can see that the Royal Navy was almost on parity. You had about 22% more ships align superiority. But you then look at throw weight. The disparity between throw weight between the British fleet and the French fleet were very, very much smaller, as you can see here. So the disparity is closer, but also remember, you're looking at the throw weight of the larger ships. And we had less dealing with a 64-pounder. The cannon weights, again, sort of looking at the sort of disparity. The French and the Spanish, and especially the Spanish, had much, much more lightweight guns, as you can see here, than their allies, the French and the Royal Navy. Again, trying to actually count the number of carronades is actually a very difficult thing, because it was at the discretion of the captain, simply sort of going, how many carronades can I put on the upper decks, and trying to get the maximum amount of firepower out of it. The carronade had replaced the 9-pounder on the upper decks of most first rates, second rates, and third rates. And again, this is probably a reason why the Border Ordnance invented the 9-pounder on the block trail for the British Army, because it had a huge amount of ammunition made for the 9-pounder and couldn't find anybody to sell it to. The Border Ordnance really sort of acted independently and was more like a merchant than anything else. It would supply cannon to both the Army and the Navy. Breaching the gun, it's important to secure the gun. This is where rope and the importance of rope comes in. And again, looking at the diameter of rope, I mean, it's amazing sort of thinking about that. That's a 7-inch rope for a 32-pounder or 42-pounder, and a 5.5-inch rope even for a 12-pounder or an 18-pounder. So it's again sort of looking at that side, and look at the again sort of going, I can visualize a 2-inch rope. 3-inch rope is getting rather heavy and thick, but the requirements of a 3-inch rope when you're trying to secure the gun. Here we have a French gun. There's less rope on the breech, so because there's no loop on the cascabel, which is the button on the back of the gun. And again, it's not as secure as you would have on a Blomfield gun. Also, it's interesting, it was Wilkinson's brother that went to France during the Revolutionary Wars and taught the French how to make good quality iron guns and also horizontal boring. This is how you would restrain a 24-pounder when you were at sea. There was no fight in it, etc. This here, where it's just below X, is the hatch, gun hatch, and you don't want 24-pounders moving around and destroying parts of your ship, and potentially it could go out the other side of the ship if it rolled severely. This is, in effect, run in, so you can then start loading the gun. This is running out, and you can see where the various tackle actually is. These are the various ways of rotating the guns, and you can see here is giving you an idea of the traversing of the guns in the porthole. This is supposed to be British. There's so much wrong with it. It's a German artist. It's got an iron gun, the elevating screws going through the cascabel, and it's using match, none of which was used by the Royal Navy. And it's a better representation probably of the French Navy or the Dutch Navy from it. And the gun looks rather small. It looks more like a sort of short gun or even a howitzer. The British used the lock. And this is a very, very important thing. It would make sure you could actually fire when you want to fire. You had far less issues with having a lighted match anywhere near gunpowder charges, etc. The gun locks give a swift ignition rather than a fuse or a trail of gunpowder. The problem with a fuse is that it will actually expel itself from the touch hole, and you've got a lighted piece of fuse, and potentially that could be a danger. The British had superior gunpowder, solid bore the guns, so we were able to actually triple shot. Again, sort of going, the guns no longer blew up. So they had reliance upon it, which means you could use higher charges and double and triple shotting. Gun locks were not lit, were no longer lit with slow match to ignite charges, superior ropes and blocks. Accuracy and precision, superior gunpowder that burned consistently and fast. The problem is that if you don't know, trying to get to that critical number of atmospheres, about 1,000 atmospheres, you would have problems if you've got a slow burning or too fast burning. You've got difficulties over the unfortunately ship's pitch when you're trying to fire. So again, sort of going, you could have the problems of inaccuracy due to that. The British spent a lot of time live firing rather than dry firing. The problem is if you're stuck in a harbour, you can't live fire. It's not safe to anybody on land or at sea doing so, and the lack of gunpowder. Good captains would buy up more gunpowder than they were actually allocated, and they would quite often use the less good quality gunpowder so they could actually go and do blank firing and some live firing. The speed of fire, this is sort of a misnomer. It's really about seamanship, the ability to get close and into a position to fire. And the rest I've already talked about. Thank you very much. Hopefully that's been an interesting, it's been a gallop through heavy artillery, and there are so many areas that I could probably spend a lot of time talking about. Thank you.
Okay, thank you everyone. Fascinating conversation so far. I'm about to end our recording, but please stay online as we continue the chat. To wrap up this month's Rally Point, thank you, Dr. Stephen Summefield, for joining us. Thank you, Stephen.
Thank you,
Thank
Stephen.
you.
For those of you who have joined us live this evening, thank you for your time with us. Next time, why not join us here at the Rally Point next month when we will do our annual November wrap-up. Simply contact Dom and I for your Zoom invite. Our details are at the end of the video, and share Rally Point with your friends so we can hear from them as well. Any previous Rally Point chats are up on our YouTube channel, and if you've enjoyed this Rally Point, please leave a quick review. So it's good morning from me, and it's good night from him.
Good night.